Hello everyone, welcome to all of you. I'm Megha from Computer Club SGSITs. This session is for Impetus Present Hackathon powered by Grow. Hope your hackathon is going well, you all are enjoying the hackathon. In this session, we are going to talk about Git and GitHub. We'll be covering its intro in it. This session will be taken by Simran Makhija ma'am. She is a GitHub Campus Expert. She has worked in Goldman Sachs as a summer analyst and in Curl Script Foundation as city lead in Steam Labs as web development intern. She has also worked in various technologies like Java, jQuery, Bootstrap, Angular, and more, and has a very good leadership skill. She is also a Microsoft Imagine Cup 2021 national winner. So thank you so much, ma'am, for joining us. With that, over to you, ma'am.
Thanks a lot for this illustrious introduction, I should say, because that was a lot. I'm humbled. Thank you. Thanks a lot. Thanks for having me today. So, hi everyone. I hope everyone's having a good morning. We're going to be talking about something very basic to computer science and programming that we use in our day to day at times. Um, so, I hope you're all having a great time hacking. I'm sure most of you saw me at the opening ceremony yesterday. So, how's everyone feeling? How's the hack going for everyone? Let's just quickly take a pulse check, maybe. How are we feeling? How are we doing? How's the hack going? Enjoying ourselves in the live chat? Okay, let's just skip to the useful work. Let's not chit chat. Fine. So, we're here to talk about Git and GitHub. So, Git and GitHub are two different entities that we see used together many a times. If anybody is familiar with either, there is a difference between the two that we will be speaking about. There are, so if anybody wants to leave in the comment while I'm talking about Git, what GitHub is, that'd be great. So Git is a is a software for tracking changes in any set of files. So even though we see Git used very commonly by a lot of developers and in the software world, you could use Git to keep copies of perhaps your college notes as well. So, Git is a version control system. What do I mean when I say version control system? A version control system means it is something where you can keep various versions. It helps you track various versions of the same file or same data and keep it in a manner where you can track these versions and go back to an earlier version if you wish to revert that way. So it is usually used by software professionals, but it is something that we should all know. Has anyone ever tried to update a file in Google Docs and seen that there is see changes? If you're collaborating with a bunch of people, you can see changes in previous versions in Google Docs where there are older versions of the doc that you may have created. For example, somebody wrote an entire report for a project and their friend came in and accidentally deleted the conclusion paragraph, and it has been saved to your drive. What do we generally do? This is possible. If it's something you guys have not explored, take a look at it. What you can do is you can go and look at previous versions of your document and restore any previous version starting from the first day. This is how version control systems work, wherein you have various versions of the same just various versions of the same document, and you are storing them as one as and these and you can revert to an older version. So version control system, if I were to talk about the formal definition, it is a class of systems that are responsible for managing changes. So any changes are managed by version control systems, and Git is a programming language that helps you. Git is a is a tool, a software tool, a programming language that helps you do this version control on your local systems when you install Git on your local system. So I'm just going to quickly start sharing my screen and show you how we can install Git on our systems. So I hope everybody can see my screen and yep. So I search for Git and you can go into downloads and you can either clone Git through GitHub, but you would need to have Git for that already. So that is a little redundant. So here you can see you can have it for any OSs, that is operating systems. If you use Mac OS, you can have it for Mac. If you use Windows for Windows and for Linux, Unix here. So let's just go into Windows and your download starts. It starts downloading an executable file. I already have Git, so I'm not going to download it. It starts downloading an executable file based on your setup, which could either be 32-bit or 64-bit. And you can just you can download it and then run that exe file, and that's it. You have Git in your system now. What Git comes packaged with is a Git bash. So to check if you have Git in your system, you can just go to search on your you can just search for Git bash in your applications and you should be able to find it. We'll be looking at how Git bash looks in a bit. So that's a bit about Git. Now let's talk about GitHub. So what is GitHub? GitHub is a provider on the internet hosting for softwares and version control using Git. So GitHub is an online platform that helps you store these softwares or changes in repositories. It helps you store them in various repositories wherein on the internet, so that you might, even if you lose something from your system, from your local file system where you have probably done some version control and used Git, if you push these changes, we will talk about what push is in a bit, but if you push these changes or upload these changes to GitHub, they're never lost that way. So we're gonna look into how to download or how to start working with GitHub right from creating an account. So let's get into it. If anybody has any doubts regarding the difference between Git and GitHub, be sure to leave them in the comments and I'll come to it later. So we're gonna search for GitHub and go here. This is the home page for GitHub. It is so beautiful. We do get lost in this quite some time, but if you're new to GitHub, you can sign up or sign in. So what is sign up? Welcome to GitHub. Let's begin the adventure. So I'm gonna create a new profile using my um, school ID. So let's go with that. Continue. Oh, it is already taken. So I'm gonna try with a different one and continue. And I create a password which is, well, use a strong password and don't say it on stream. This is something we learn. So here, and username, I'm just gonna keep it sim extra because this is not my first account. I'll probably change this username later. Oh, it's already taken. So then I'm gonna go with my usual username on various other platforms. Oh, it is also already taken. Let's just do it Simran at hack it out. So Simran dot hack it out because that's where we are today. You can use any username of your choice, and so this is Simran hack it out and it is available, so we continue. Would you like to receive product updates? Let's just say I don't want any disturbance. And okay, we've got to solve a puzzle. This is Spiral Galaxy. It's taking quite a bit. And there we go. It is this easy to create a GitHub account. You'll receive a code on your email ID, and all you have to do is enter that 6-digit code, and we're done. It's just me and I'm a student. We continue collaborative coding. Let's just talk about collaborative coding today. We're gonna talk about how we can um, go into the details of this, which is gonna start for free. For free is enough for us. You can also avail the GitHub Student Developer Pack, for which I'll leave the link in the comments quickly. I'll just have to look for it. So I'll leave it in the comments towards the end. Using GitHub Student Developer Pack, we get GitHub Pro for free. So you have this nice little screen where you have no repositories. As I was talking, we can create a new repository and go from there and start using it on our systems. I'm just going to check back for any questions in the comments. None. Okay, let's keep going. So I create a repository, and this is a hack it out demo. That's what we're gonna call it. Description demo for hack it out, or I gotta brand my hack directory. Oops, there. For hack it out and add a readme file. So it is a good practice always to choose a license for your project before you start, because that ensures you with like an MIT license is a good license. You should look into licenses if you want more creative ownership and want a restrictive license. But these licenses ensure that your open source product or project is licensed to you. So and you can use a git ignore template. Like if you're working with JavaScript, you can find a node template here which would essentially create a git ignore file with node modules. If you've seen what node modules are, if not, not to worry. What a git ignore file is essentially is a list of files or folders that you want git to ignore, that you don't want git to track. Like you don't want git to track your node modules because you have a different tracking mechanism for it, which is a package.json you would have in a node project. So this git ignore file would tell your VCS, your git, to ignore this set of folder files within this folder, or maybe you want git to ignore your environment variables, right? Because those are your secret keys. You would essentially not want them pushed to a public repository. So those are the kind of files you would add to git ignore. And a README file, again, a good practice to have in a repository. This is the first file that any user sees as soon as they go to your repository code. And a README file usually has just the content of what a brief description and some steps to get started with the project, maybe some steps to run the project and create repository. So here we are. See, this README is created. It has a short description that I gave. It could be a better description, but well, we have this here. Now we're gonna see how we can sync this with some files on our system. So this is a public repository that we have, and it is up there on the internet for the public. But I can't really add files from my system here. I can upload a file from here. I can probably drag and drop or choose. But what I want to be able to do is to track changes within the file system of my project, which I have on my system. For this, we'll be using the GitHub CLI, which is the command line interface. And as I mentioned a few minutes ago, we'll be talking about GitHub Bash in that context. So let's just quickly grab this link from here, and we'll use it to clone the repository on our systems. Cloning, the word literally means to make a copy. So what we're doing is we're taking this public repository and making a copy of it on our local systems. That's what we're doing when we're cloning. I'm just going to share my entire screen quickly. There you go. Now you should all be able to see my Git bash as well. So here it is. Seems to be loading. I'm gonna place it here and make it a little bigger. So we on the Git Bash is a Bash shell. It is a CLI shell where you can use Bash commands. So, and the command, since we've already installed Git, we have all Git commands here. I'm just gonna go and change my repository to desktop, my location to desktop. Oops, go find, let's ls, and we're somewhere. Okay, my desktop is in OneDrive. So I'm just going to go onto my desktop, and here we will now just go into full screen here, and we will now create a new uh, directory, which is git demo, and within this directory we will clone our repository. So here what we do is git init. This is a command that is used to initialize an empty repository in Git. That is, now as soon as you git init, you're telling the Git control version control system that you have on your as soon as you get in it on your system to say that I want you to track the versions of this file for me. I want you to track what changes I make and show those changes to me in the git status command, which we'll get to really quickly. So when we run git init for the second time, it reinitializes our GitHub repository here and creates a hidden file that goes by .git, which essentially has all the data about all the changes you'll make to this repository. Now we're gonna run the command git clone as we just discussed. Cloning is the process of copying of copying the repository from the internet to your system. So here I'm just gonna copy the link and paste it, and here we go. It's cloning. Now you might and if we were to ls here, we can see hack it out demo is created uh, as a new directory here. So this is one way to do it, that you create an empty project on GitHub and then you clone it to your system and start working on it afresh. Since we're a few hours into the hackathon already, I'm sure a lot of you already have some progress that you'd want to push. In that case, I'm just going to create mkdir demo2, and I will cd into demo2, and we'll git init here, create an empty repository here. Now, if you were to connect that your repository on the internet with something here on your local system without having to, without having to uh, start from scratch, copy your files into a new location, all of that is really cumbersome. So maybe, excuse me, I'm just going to quickly create something that is less uh, friendly. We've discussed everything about README and all already. So we're gonna go here, and you can see I created demo2 and I copied the link from here. Yeah, I copied an entire command from here, and we'll talk about what that is really quickly. So we have git remote add origin. So we already have a GitHub repository. All our Git commands work in here. Now what we're trying to do is we're trying to link this to something on the web, a public repository sitting on the web, which is at this URL. So when we're linking this to that, what we're doing essentially is adding a remote to this repository so that it can be tracked from that public repository as well. A remote is something that we often use with a lot of our devices, with your AC, with your TV. Similarly, this remote helps you control your repository on GitHub. So we are adding a remote by the name of origin, which points to this repository on the web. So let's go. Now, if we go git remote, it's going to show origin is added as a remote. Since we don't have any files here, let's quickly create a readme file and paste it here. So now if we ls, that is list all files we have, we see readme and md, and This is the best thing about the bash, git bash. It is a bash shell. You can use all Linux commands that you would is usually use on the bash shell in your Windows system. So as you can see, readme looks like this. Now earlier I told you when we git init, we're basically telling our local system to track changes and show those changes to me when I run the command git status. So let's run git status and see. So we see we're on the branch master. GitHub has a concept of branches. Git has a concept of branches, excuse me. And branches are essentially various pipelines on which various developers can work. That is, the master branches where you put bring together all your work from various different people or the various different features, but in and you could create different branches to work on your own for features for an individual feature or for an individual person. What this helps you do is this helps you develop seamlessly in parallel, and it is very easy to merge these branches and bring them together in the master branch, as we're going to see in a bit. So this helps you develop together and seamlessly merge those changes. So as this says, we're on branch master. There are no commits that we've made, and we have one untracked file. So what git status does is it just shows us the status of the GitHub repository on our system. So we have created the README file, but we actually haven't told Git that it exists. We haven't added it to the list of things that Git should be tracking. So our first course of action is to git add readme.md. So this is just a Windows to uh, Linux thing. File endings, line endings are changed there. So git add readme.md. Now, if I git status, it tells me there are, oops, typo. It tells me that there are no commits yet, but there are changes that Git knows exist and are to be committed. So the next time I make a commit, that is, I in my working version control, I tell them ki these are the changes I've made, and I want to push these changes to store these changes in a commit, so that if I make more changes later and they don't work out for me, I can revert to a commit. So a commit is basically telling Git that you save these changes in one packet, and this current condition of my repository with this ID, like a commit has an ID and it has a message that we can write with it. So we're gonna try and git commit -m to say this is the message. It's a flag that we use with the command to say this is the message that we're going to put in. So add readme, which is not a very good readme. And there we go. Now we have committed our changes. We've committed our changes. We go with git status, and it says on branch master, nothing to commit, working tree clean. That is now your all the files that you have here that aren't a part of your git ignore, that are files that are being tracked. All those changes have been added to git and saved in a commit. In this working tree, there are no changes that git is not aware of or is not saving. Now I have this here. Does this mean that these have been synced to my GitHub directly? Let's find out. If I reload here, I really don't see a readme yet. So my changes haven't been pushed to my GitHub repository there on the web. We added a remote. We use that remote to connect these two repositories, but when we make a commit on our local working directory, it is saved as a part of the git logs. Git has logs of all the changes we have, right? So as a part of the git logs there on in your working directory, but it does not push anything to the remote unless and until you tell it to. All you have to do to tell git to push is run the git push command, and it wants me to uh, the first time you do it, you will have to set upstream, and set upstream is basically we're setting the default branch and remote that we want to push to. So we're doing this. Okay. This is not allowing me to make a push here because permission denied. Okay. So basically, I have two GitHub IDs and my default GitHub ID is being denied permission here. So might as well talk about how you invite somebody so that they can push to this repository, right? So I'm gonna invite myself here, and this is my primary GitHub ID. I've been added as a contributor here. Did we do it for? Yep. Now I'm just gonna have to just a second. Do we have any questions? Do you have any questions in the process up to this point, and we can talk about them in the meanwhile? Okay, let's then get back here. So what I did here was I requested my other ID for, I invited my other ID to collaborate here and accepted the request from the email I got. You can add as many collaborators as you want. I'm just gonna try and add a teammate of mine here, and so it's that easy. All you have to do is enter their GitHub username and an invite is sent. Now we should be able to push because we have permission to do so, and done. Our changes are now visible here, demo 2. So it's this easy to push any changes to GitHub and create any files here as we just saw. A few more useful commands that I referred to earlier was about being able to create various branches. So to create branches, again, there are two ways. You could do something here, view all branches, and you'd see there's just master. I go back here, you have find or create a branch. So if I try to create branch one, and there isn't a branch now from master, it says create branch one from master. What this does is it creates a new branch which has all of the commits and all of the content of my master branch up to this point. So that's done. It has created a new branch for me. Can I see the branch here? So to see any branches you have, you'll have to run the command git branch, and all I see is master. Why is that? Because again, your local repository and your public repository hosted on the web are not synced unless you give them a command to push commits or to pull something new that has happened. So I don't think the commands could get easier than this. Push to send something to the web, pull to get the changes from there. So we're gonna run git pull and new branch one origin is created on over here, and now if I run git branch, hey, we're on master. I think the command for viewing all branches is different. Let's git search for it. I mean, we all forget, right? That is git branch shows you the branch you currently are on, and let's try git branch hyphen r. Oops. Okay, this shows us the list of all branches we have, and as you can see, we have branch one here. Now, what should I do if I were to? Sorry for the disturbance there. If I were to still, if I run git branch, it's just gonna say I'm on master. Now I want to switch to branch one. So what I can do is git checkout. This is the command that we use, checkout, to switch to a branch. and branch 1. Switch to a new branch, branch 1 set up to track remote branch from origin. What does this mean? We have switched to a new branch. A new branch has been set up on our local system, and it has been set up uh, in accordance with branch 1 on the remote origin, which is the remote that we added earlier. Now, if we get branch, we're on branch 1 and we have master there. Pretty easy, right? Switching branches, working on branches. Let's look at README here, demo 2. Okay, let's try and open. Okay, sorry. Does this work here? Because of the wrong spacing. It does. Yes, it opens Visual Studio Code to this directory. This is a very useful command, code and dot. It opens Visual Studio Code here, and let's make some changes. So I have autosave on Visual Studio Code. It lets me, so I don't really have to control S every time. I'm gonna turn off autosave just to show. And Visual Studio Code also has source control. So I'm just gonna write this is a second demo project, and I'll save these changes. As soon as I save these changes, you can see here in source control, it shows me some changes that haven't been added. So again, if you're using Visual Studio Code as your code editor, you can add them from here, or as we did earlier, using git add. So we can add them from here and commit them. So add description is, so again, it's very easy in Visual Studio Code. You just need to type the commit message over here. You have the stage changes as soon as you add the commit message here and do this. You have made your commit. Done. Now, of course, the commit has been made in your local directory, and we do still need to push the commit to our, okay, this much laziness is not good. So let's just type git push, and this helps us push to branch 1. See, this is the commit ID, and this has been pushed from branch 1 to branch 1 on this repository on the web. Let's see if we have the changes here. Reload. As I said, this is for people to be able to work parallelly. So you'll see branch 1 has the description while the master branch has nothing. So how do we reflect these changes in the master branch? One way to do it is you open a pull request and see if they can be easily merged. It says able to merge. Let's just try and create a third branch called branch 2, and let's edit this to say this is a second demo project for hack it out, and update readme, commit changes. Small changes you can always make from the web. So now as we can see, demo 2 and demo 1 have different things on the first line of the description. And so we're just going to go into branch 1 first and try to create a pull request. Now a pull request is basically we pull from something when we want to take those things into our branch. So we're requesting branch master to pull from branch 1 these changes that we've made. As you can see, it says that we are able to merge. They can be easily merged. There are no conflicts. So it's pretty easy. We create a pull request. Now creating a pull request is not always necessary, but it's a good practice. It shows you if there are any merge conflict that you need to resolve, and if there are, then you make sure that you accommodate for the conflicts. So we've merged branch 1 with uh, master. Now we can see this is a second demo project. Still branch 2 has for hack it out, and we didn't edit anything on branch 2, so branch 2 has this is a second demo project. I'm just gonna change something here for HIO perhaps. Let's have two different things here. So now we have branch 2, and it is, if you go back to the code, it says it is one commit ahead and two commits behind master. That is, there are some changes here that have been made to branch 2 but not to master, and now you're all ready to commit your changes to master because you're sure these will run fine with the master code. So you go here and you open pull requests. Is it able to merge? It cannot be automatically merged. So nevertheless, we create a pull request. So generally, we would give some description here that says change, readme, and create pull request. Now, when you create this request, you can see that there are conflicts. So before you can merge something, you'll have to resolve conflicts. It shows you that branch 2 has this text while master has this text. Which of the two would you like to accept? So let's just assume we want to accept changes coming from branch 2. So we just delete this bit and this. We've resolved the conflict, we mark it as resolved, and we merge. That's it. It's as easy as that. The conflicts have been resolved, and now we confirm merge, and voila, as most people would say. I don't always pronounce it correctly, but here we have it. And branch 2 has also been changed accordingly to make sure that the conflict doesn't happen again. These are some very basic things about Git and GitHub that you will find useful to you in the scope of your project in the hackathon. So, uh, are there any questions anyone has? I'd be happy to take them now regarding Git and GitHub or regarding the hackathon in general. No? Okay, I think then with that, we're done with this session for today. And I hope you're all having a great time hacking. Thank you all for tuning in. Um, Thank you, Sudeep. It's great to know that you learned from this session. And so, thanks a lot, everyone, for joining in. Back to you, Megha.
Okay, thank you so much, ma'am, for sharing your knowledge with us. The way you explain everything is very perfect. That if there's someone who doesn't started using it, then we'll definitely start using it from now. As it become very easy now. And thank you guys for joining us.
I think we have one question. Do I need to remember all these commands? Not really. Honestly, you do not need to remember any of these commands. Some you'll get, very used to very quickly because they're um, very often used. But as you saw, I didn't know how to list all branches. I couldn't recall, so I googled it or searched it on Bing in front of everybody. So all you have to do is run a search if you don't remember something, and there is a helpful tool that I would like to share with everybody for if you cannot recall commands. There you go. It's in the chat. This is a cheat sheet that GitHub Education provides for all GitHub commands. So this can be your go-to if you're looking to, if you forget any commands or if you're looking for definitions of what a command is, how you're supposed to install Git and all of that. You can find it all here. Yes, Megha, would you? Sorry.
Uh, okay, thank you, ma'am. And thank you guys for joining us.
Bye bye. Happy hacking, everyone.